Welcome to Khetz Tutorials, and in this video, I'll be covering question 71 from James Stewart Calculus in D exercises. So we're asked to find the x values or the angles between 0 and 2 pi inclusive, which will solve this equation. And to do that, we're going to first convert our tan into sine over cosine. And we can multiply both sides by cosine, giving us sine cosine equals sine. After this, we can move this sine to the left hand side, and this is what we have. Now be careful, if you were to divide both sides by sine, you'd lose some of the answers in most cases. So try as much as you can to get to this point where you can factorize and keep all of the trig functions that you initially had. So if you factor out sine, then you're going to have cosine minus 1 equals 0, and you can now solve this. So sine x equals 0 or cosine x equals 1. You can now focus on finding the general solutions on each side, then make sure that your final answers are actual angles and they fall within this restriction. So let's start on the left hand side. The left hand side, the steps are, you're going to find the reference angle, decide where this is on the cost diagram based on its sign, then use that to complete your general solution. So that's 0. We're going to assume that it's neutral or positive, and that would lead us there for sine as well as there. So those two positions. Those two positions are described by 0 plus, because plus is counterclockwise, as well as pi minus. So pi, then minus. That's how you get to that point there. So let's write that. Our reference angle or arc sine of 0 is 0. So x is a description of the portion starting with 0 plus the reference angle, which is now also 0. That's the arc sine part. Then plus the period of sine, so 2 pi multiplied by n, which is an integer. Then the other portion where sine is positive is pi minus, then the reference angle plus our period again multiplied by an integer. Okay, so let's substitute integer values that will give us angles which are between 0 and 2 pi inclusive. Starting with the top one, we just have 2 pi n. So if you substitute a 0, you're going to have an x of 0. Substitute a 1, we're going to have 2 pi. If you substitute anything else, it will fall outside the restriction of 0 to 2 pi. Then with this one, we have pi plus 2 pi n. And so if you substitute a 1, we're already at 3 pi, which is outside. If you substitute a minus 1 over there, we're going to have minus pi, which is also outside. But if you substitute a 0, we're going to have pi. So that can be given as one of the solutions. Everything else will be outside the range. Coming to the right hand side, the reference angle is arc cosine of 1, which is 0. But this is a 1, which is positive, so we're going to look for places where cosine is positive. Cosine is positive at 0 minus as well as 0 plus. So we're going to write our x solution as 0 plus our reference angle of 0, then 2 pi n, and n is an integer. Then we're going to have x at 0 minus, so it could have been compacted by saying 0 plus or minus the reference angle to describe these two portions. So this describes the two portions, then this is our reference angle, then added to the period multiplied by n. So in any case, this is just 2 pi n, and is an integer, and we can only substitute a 0 there to get an x of 0, but we already have that as a solution. So these are all the x values which we can get, which are between 0 and 2 pi, using this equation. And that is how you'd solve this.